might still be sinking right now. AB to the x, AB to the x power, where A is the initial value, your starting amount, B equals 1 plus R, where R is the growth or decay rate, 1 plus R. So if I said you're growing by 50%, what's the B value going to be? If I said something is growing by 50%, what is B going to be? Nope. 1.5. B is 1 plus R. 1.5. If I said B is 0.5, you'd be decaying at 50%. You'd be super careful. What's nice about growth, exponential growth and decay, if you do a reality check on word problems or anything involving units that you recognize, if you don't do the B value or the R value correctly, what'll happen? You end up with totally absurd answers like, what's the growth rate? 6 trillion%. You're like, no, that's not right. Or like, how many kids does Sally have? 58. You're like, I think that's wrong. You know, something like that. So the key is the structural differences here. The growth will go up and the decay will go down. They look like mirror images of one another. They look like mirror images of one another. Nice. Okay, so you can answer questions like this. Linear, exponential. How do you tell, and I wrote in some of those numbers there for you, how do you tell if a function is linear or exponential? What's the definition of a linear function?
The increase, like the slope is constant.
The slope is constant. So every time you go up by the same x value, you go up by the same what? Y value. So look at f of x. What's happening as you go up 1 each time? What happens to the x values? They'll go up by 2. What about g of x? What's happening there? Is it a constant difference?
No.
No, but what's the same between each consecutive set of numbers? The what? The what?
Average.
Not the average. No, close. 6 is to 2, 18 to 6. 50.
Oh, it's like a pattern of how you divide.
Ratio, the ratio, pattern, yes, pattern of ratio. So the ratio is constant. What's the ratio here? 3. What's happening? Every time you go x goes up by 1, what happens to the output? It triples. It triples. So which one's exponential? G of x is exponential. The ratio is constant. The ratio is constant. So what we're going to do is actually do a couple of these questions here. We're just going to, that's the beginning part of it, and here's a question here. So let's do a real question here. So get up to the board, everybody. Get up to the board. Get up to the board. Let's have Andrew and Natalie work together. Let's have Whipple and Noah work together, and then everybody else together. The half-life is 3,200 years. Find the time it takes for it to decay by 35%. 35%. So we need to figure this out. Y equals AB to the T. AB to the T. What's the, so how do we do this here? Yeah, what do you think, Arvin?
Reset.
Okay, first of all, what are we trying to solve for? We want what?
I was going to say,
hold on. We want
B be a decay rate of 50%.
Hold on. Stop. Which variable up there are we trying to solve for? Yes. T. It says literally, find the time, right? So we want what? T. So we're trying to fill in everything else. We need to fill in everything else if we want T. Y is the output. A is what you start with. So the question, Noah, is how much do we start with? Does it tell us a tonnage? Does it tell us a grammage? No. So what do we start with? We can pick whatever we want. What number should we choose? 1. A equals 1. That's how much radioactive material we start with. So if we want to decay by 35%, how much do we have left?
65.
So what does Y equal?
Y equals 1 times 0.65.
So how much do we have left? Yeah, 1 times 0.65, which is what? 0.65. So let's throw in what we know. We have this. 0.65 is equal to 1 times what? B to the what?
Isn't B?
B to, let's piece by piece here. Are you okay with what I just started with?
Yeah.
What's going on here? You're starting with 1 unit of radioactive material, and something is happening to it, and you want to end up with 35% less. So that's 0.65. We want T, so now we need to figure out what B is. Take a minute with your partner and see if you can figure out what B is. No, and I'll need to unfreeze this. You still know, Y is equal to AB to the T, correct? So if you started with A and a half-life of 3,200 years, you know that after 3,200 years, how much of A do you have left? Half of it. So after 3,200 years, how much of A do you have left? Half of it. Why is this really helpful right now? What can you cancel from both sides? You can cancel A, end up with 1/2 equals B to the 3,200, right? How do you find out what b is? Oh, the 30. You got it. B is equal to the 3200th root of.
But wouldn't that be
Yeah, that's what I,
So listen, stop for a sec. That is the b value. This is the b value. So what do you do with this now? What do you do with this now?
Enter it into the other equation for B.
Oh, so now what do we have here? 0.65 is equal to what? What was it? 3200. The square root of what?
1/2.
All the way to the t power. Use your calculator and solve that for me. Go.
It's frozen.
It's frozen? Okay. So how do I do this? If I want to find a 3200th root of 1/2, what do I do?
Do 1/2.
0.5 to the what power?
The 1 over 32.
1 divided by what? 3200. And I press what? Enter. Now, do I write that decimal down? No. What do I do instead? Store it as, let's say, alpha A. Ready? Every time I type A in my calculator now, what value is it? That one. Let's go back here. So now, how did I write this? Well, I'll use A instead. 0.65 is equal to A to the T. That is in exponential form. Everybody stop typing right now for 1 second. How do I write that in log form? You have to remember this. This is something that's real important. Just guess.
Left or right?
Log base. Log base what? No, close. Log base. A of what? 0.65 is equal to what? T. The way you remember that, everybody, it's a circle. A to the T is equal to, you see that circle right there? A to the T is equal to 0.65. These are the same. Those expressions are equivalent. Now, why is that really nice now? Well, there's a rule. Does anybody remember what this is? Log base B of C, what that equals? Log of what? Anybody remember? C over log of B. That's a change of base formula. So what can you do with this now? Log of what? 0.65 over what? Log of A is equal to what? T. So we go back to our calculator. We go back to our calculator and do log of what? 0.65. Press enter. And what do I divide it by? Log of what? Now, I just press log and, oh, there's log of A, right? Like this? Look at that. What did I get? 1,988. Is that within reason for what we estimated?
Yeah.
All we knew is it had to be less than what? 3,200. Exactly. All we knew is that it had to be less than 3,200. And is that less than 3,200? Excellent. Excellent. So are you a little hazy on your log work? I'm sure it's a little weird. I'm sure it is. We will practice a ton of it. We will practice a ton of it. Okay, so let's do another one, okay? Give me a half-life. Give me a half-life. Yeah, what's a half-life going to be? 20 years? Sure. Decay by how much? Decay by 90%. I want you to tell me how long it takes something to decay by 90% if the half-life is 20 years. Do that for me now. Percent. So you're solving this. 0.10 is equal to... Oh, equal to frozen. 0.10 is equal to what? What do you... B to the T? But you need to find B, right?
Yeah.
So you know that, what's the half-life? You use the Arvin technique over there that he put up. Half of A is equal to A times B to the what power? 20, so that cancels. So what's B equal to? The 20th root of 1/2. So you have 0.10 is equal to the 20th root of 1/2 to the what power? So you'll need your calculator for that, but it's going to be log base 20th root of 1/2 of what? 10 is equal to T. So T is equal to log of 0.10 over log of the 20th root of, that is the same work we just did with different numbers. Plug that into your calculator and what do you get?
Like 66.
60 what?
I got
66.
66,
I got
right?
negative
Yeah, that's
1.1.
Okay, negative can't, we're talking about positive time here.
437.
Did you type that into your calculator?
Chris and I both got 66.
Yeah, it should be around 66, I think.
Yeah, it is 66.
Did you, now, do you agree that this statement is correct?
Yeah.
Okay, do not try to type that whole thing into your calculator as one statement. You will type it in wrong. What did I
I
do?
put log 0.10 and it came out as -1. Is
Yeah.
that mode?
No, that's fine. Log 0.10 is negative 1.
And then I did that divided.
Yeah, so let's do it again. That's totally correct. You did it, right? So we do 20th root of, what is it, 0.5 to the what? 0.5 to the 1 divided by 20, like this. And then I store that as, let's say, alpha b. So then it's going to be, oh wait, thank you. Delete answer B, great. Let's just, oh, it's saved there. So then what do? Log of 0.1 divided by log of alpha b. Oh, that's the wrong button. I know. Press enter. 66.438. Oh, nice.
That was close.
And the reason it takes that long, you can do this logically, everybody. So if you're at 1 of something, take one step, you're at 0.5 of it, right? And then what do you add at it? 0.25. Then what? 12.5, right? 12.5%, right? Well, 0.125, right? And then you take another step, and you're going to be past it, right? So this is 20 years, that's 20 years, that's 20 years, and so it's going to be 20 years plus a little bit times 3. What's 20 times 3?
60.
So what's that little bit? Six more years. Yeah, exactly. Okay. So let's say this one. A population grows by a total of 30% every 5 years. Find the doubling time to the nearest month. So here's a chart of what's going on. A population grows by a total of 30% every 5 years. Find the doubling time. What did I choose there that they didn't give me in the question? What did I start with? What does this question not give me but I started with?
Zero.
Number of people. It's asking for a doubling time, right? The doubling time should work with regardless of the number of people you start with. So if you are free to choose a number of people that help your logic make more sense, choose a number that's nice. What number is really nice? 100. We're talking about doubling and decaying and exponential growth. Start with 100. So at time 0, there's 100. So after 5 years, how many people are you going to have? 130. Okay, and then after 10 years, you're going to have 1.3 of that. And, oh, look at this. So I've kind of filled it in here. You see what's going on here? So what has happened after 15 years? We started with 100 people, and then what did we end up with after 15 years? So what's our guess going to be? What do you think what is our guess going to be? What's the doubling time? In 15 years, we went from 100 people to 219.
25.
In 15 years, we've more than doubled the population.
Oh, okay, we started with 100, okay.
13 years, around, right? Now, the difference between a guess and finding an exact number is actual algebra this time. Okay, so what's going on here? So we have y equals ab to the what? To the t. And we chose what as our starting value? 100. So if we started with 100 as our starting value, to double it, what would we end up with? 200. Oh, this looks familiar. B to the what? B to the t. We are trying to solve for what? B or t? T. It's asking for what's the doubling time. What's the doubling time? So in order to solve for time, we need to get rid of that b. We need to plug something in for b. How do we find the b value? How do we find the b value? How do we find the b value? Yes, Chris.
From this equation, you divide by 100 and then.
No. We need to do.
Method, right?
Yeah, we can do. It's called the R resistance. So what do we do here?
Use the initial.
So tell me, what statement are we gonna have? What's this first statement tell us right here? What's this first statement tell us? A population grows by a total of 30% every 5 years.
You have the time and the percentage or the rate.
So what's the line going to be?
0.3.
Not 0.3. It grows by.
Oh, 1.3.
So 1.3 times A is going to be equal to A
B
to the what?
the
5 years. Yeah, exactly. Is everybody okay with this? What cancels? The A value cancels, and you have 1.3 equals B to the what? 5. So log base what? Log base B of 1.3 equals 5. Remember, it's the circle. Remember this circle thing? It takes a little while to remember. That's fine. But then there's the change of base formula. What does that tell you? Log of 1.3 over what? Equals 5. Is this helping us here?
No.
What's going on here? How do we do this? Oh wait, do we need logs to do this? That's not what we used. What did we do before? We just took the what? Fifth root. So what does b equal? The fifth root of? Fifth root of 1.3. So where do we plug that in now, Arvin?
Put that into that.
So 200 is equal to 100 times the fifth root of to the
Growth ones are just easier.
growth and decay are going to, it's going to be the exact same. Exactly, yeah. A little bit, like one less step. So now, can you solve that on your calculator? Do that on your calculator for me right now, please. Go to 3 decimal places. You do the fifth root of that, so you end up with what? 2 equals the fifth root of 1.3 to the t. Did everybody get an answer? So this t should be 13.21. Do I need to do it out again? Can you do this on your calculator?
No.
Yes. You want to do it again? Okay. So you have to do, it's the same thing before. So you need what? 1.3 to the what power?
1/5.
Yes, 1.3 to the 1/5. That's 0.2, right? I'm going to save that as alpha c, right? So we have 2 is equal to c to the t. So it's log base what? Log base. Take a look at this, everybody. Log base what? C of t equals t. So what do you have here? Log of 2 over what? Log of c equals t. What did I have here? I totally did that wrong. It was 1.3 to the what power?
1.1.
To the 0.2 power, right? To the, we want the fifth root?
Yeah.
So I'll save this as c. Alpha c is that? Oh, sorry. 1.3 to the 0.2, right? And then I store it. I needed that store button as c. So then what was it? Log of what? 2 divided by what? Log of c. And I end up with 13.21. How do we feel about that? Like this, and put it in there. I'll put it right over here. Right there. What's your question?
Can you just divide the
Made it as general as I could. Instead of writing 200 and 100, what could I write instead?
2 and 1?
I could write a and 2a, and what does it become? 2 and 1. We just chose 100 because it's fun. It's easier to conceptualize. Yes, Alex?
Do A and B have
Only difference between that and what we just solved. What's not there? What's the difference between this and this?
Every year.
No, just literally, what number is missing?
the fifth root?
The fifth root is missing, right? If you solve this one, you end up with t equals 2.6. That's the same answer. Do you know why? Multiply 2.6 times 5, what do you get? What do you get? It's a little different because of rounding, everybody.
It's 13.
It's 13, right? We got 13.2, right? I rounded. The point is, if you don't have the fifth root in here, t is not every year. T is every 5 years. We set it up to give us the actual number of years. The actual number of years. Do you see what I mean, everybody? So units are really, really important. Just multiply by 5 in the end. I kind of like the way we did it because you don't have to remember to make that step at the end. You might be tempted to say, answer's 2.6. No. Careful. Yeah.
I have a question.
Shoot.
When you look at like, I'm trying to think of what the name was.
And then what was the other one? So 15 here. And what over there? 4? Enter. Okay, that's nice. Now what?
Then you go to,
It's okay. It's fine.
stat again,
Stat, yep.
and then
Calc, I think. Yep. Linear regression?
Yeah.
We do linreg. Enter. Calculate. Oh, I gotta press enter. Oh, look at that. You gave me that. Now, are there other regressions we can run? Yeah, so that tells us that if you want to negative 35x plus 155. Well, let's do instead stat calc. Which one do you want to do now? I think it's down here a little bit, right?
8.
Is it 8?
Yeah.
Not 0. EXP reg?
Yeah.
Let's see what EXP reg. List 1, list 2. Cool. 240.5 to the x. That would be exactly, that fits it perfectly. That's kind of cool. So this allows you to take data sets. Now, Is this a really nice data set? Yeah, it's 2 points. 2 points. Are all your data sets always this clean? No. That's why your calculator's helpful. Okay, everybody stand up, stretch.
Your interest is what you originally have.
Mm-hmm. So you had $1, and then what did you multiply to get 2?
Well, it'd just be times 2.
Times 2, and where does that 2 come from? You know it's going to double, so it's 1 plus 1. It's a lot of 1s there, right? In this case, the 1 that's the starting amount. That's your starting amount. And then what is this right here? Or I'll be more specific. So it's 1 plus the rate of growth.
Yeah, 1 plus.
Yeah, 1 represents what in percentage?
What you originally. Or
1 represents what in percentage form? 100. So it said 100%. Okay, what does twice a year mean? If I said it's compounded twice a year, what does that mean? What does that mean?
Wouldn't that be the time? Like the,
So you have your $1, right?
yeah.
And I got to write 1 in there. And then you multiply it by what twice?
2.
Do you double it twice?
No.
If you have 100% compounded twice in 1 year,
It'd be 0.5 over 50.
careful, 1.5, how many times? 2 times.
This is twice a year.
Because it's 50, you're increasing it by 50%
1 plus 50. Yeah.
twice. So if I do this on my calculator, what do I end up with? You might actually know, what's 15 times 15? It's 2.25.
Yeah.
So you get $2.25. Did we make a little more money? Okay, so what about monthly? What about monthly? Instead of 0.5, what is it going to be? 1 times 1 plus what? 1 what? Yeah, 1/12 raised to the what power? To the 12 times. Use your calculator and do that for me. Use your calculator and do that for me. When you have it raised, 2.61. Okay, so it looks like, what's happening here? We had $2 and then 2.25, then 2.61. Do you think you'll ever get to $3? What do you think?
After a couple of years, right?
No, I mean in 1 year. You only have 1 year. Basically, can you compound enough?
Continuously.
Well, let's see. What would be next after monthly if we did this kind of like logically? No, there's something. What? You do weekly? What would that be? Weekly would be 1 plus what?
1 over 152.
What? 52 to the what power? 52 power. So that would be weekly, right? And what would be daily?
I thought it was
What would be daily?
1 over 360.
Yeah, it's interesting. Sometimes books use 360.
Yeah, I thought it was T over 52 or T over 12.
No, not yet. We're doing it like this. Just keep up with this pattern for now. Do those two for me and tell me what you get. Do both of those for me. E. This is actually one definition of E. This is one definition of E. So actually what's interesting is if you continuously compound $1 for 1 year, how much money are you getting at 100%? What are you going to get? You're going to get E$. E$. Okay, sit down.
What's math for you?
How many people have seen? Yeah. Do I want? Which one do I want? Yeah. How many people have seen this before? Anybody seen that before? PERT. A PERT. The amount of money you have is your principal times e to the interest rate times the time. This is continuous interest. This is continuous interest. This is continuous interest. So, yeah, you could state that. I want to do some of the problems while I have you here. There it is, right there. It says the amount of ozone is decaying exponentially at a continuous rate of 0.25% each year. How long from now will half of the ozone remain? Well, what's the continuous interest formula? I just showed it to you. Do you remember what it is? A equals what? PE to the RT. So this says it's decaying exponentially at a continuous rate of 0.25. So what goes? Where do I put the 0.25? Where do I put it? Into the R. So I have A is equal to PE to the 0.25 times T. What am I solving for? A, P, or T? Why?
How long?
How long? I'm not highlighting it there. How long? So I'm solving for T. Okay, well half of the ozone remain. Half of the ozone remain. Yes? So yeah.
Cancel out A and P by putting, so 1/2.
So what is A going to be? You can just say, what A is going to be what?
1/2
Half of what?
of P.
Because that P is the starting amount, right?
Yeah.
So you have 1/2 P is equal to P e to the what?
0.25.
0.25 T. What cancels? 1/2 equals e to the what? 0.25 T. How do we feel about this? Let's see what happens here. How do we do logs on this one? What's this going to be? This is the whole exponent. Log base what? No, log base
Of
e of what?
1/2
Equals 0.25 T.
So divided by
What is log base e? That has a simplified notation, ln. So this is ln of 1/2 equals point what? T. So what is T? What do we think T is going to be equal to?
ln 1/2 divided by 0.25.
Do that on your calculator and tell me what that is equal to. Do that on your calculator and tell me what that is equal to.
We don't know a good answer for that.
We might have made a mistake. I don't know. Who knows?
Negative 2.7725.
Yeah, I know. Something. What'd you get here?
Negative 2.7726.
Who got negative 2.7726? Okay, so our algebra is correct. So one of our initial substitutions is wrong. What do you think it is?
No. It's the rate.
The rate. So what do you think the rate should be when it's written in this formula? So what do you think it should be?
0.75.
Do you think it should be 0.75 or do you think
Or negative point.
negative 0.25? Try that. Excellent. Excellent. So this right here should be what?
Is this just because it's money?
No, because it's the continuous interest rate formula. So when we do decay,
2.7726.
oh, is that a little bit better?
Yeah.
So it's negative, so this should be positive. Is that a little better?
Yeah.
Oh, very cool. The amount of ozone is taking exponential continuous rate of 0.25% each year. Let's see if that makes logical sense, right? So if you started with 1, if it decayed by 25%, how much do you have left? How much do you have left? 0.75 is left, right? How did you do that? You multiplied 1 times 0.75, right? To get to there? How much is left the next time? Well, that's going to be 0.75 squared. Can someone tell me what 0.75 squared is? What is that? What's 0.75 squared?
5625.
5625. So that's how much is left. How much did we want to have left? Point what? 5. So it should be a little bit more than 2 years. How much more than 2 years? 2.7726. We found it exactly. So when it's decay for continuous interest, it needs to be what? Negative. It needs to be negative. Chris, it looks like you have a question.
Yeah, the 2 is an estimate. We are squaring it up there.
The 2? What?
1 and the arrow, 0.75 and 0.75 squared.
It's not an estimate. It just means after a year, after 1 year, that's how much will remain.
Yeah, okay. Yeah.
And then how do you go to the next one? You multiply by 0.75 again.
Yeah.
It says 0.75 squared.
Yeah.
How are you feeling about this stuff so far? 5 is your grade, 0 is you have no idea what's going on. Where are you? Like 3, 4-ish? 1? Chris is still at 1. We're at 4, 3. We're A-okay? Is it A-okay right there? Okay, let's do.